To observe with Hubble, we actually have to plan out pretty far in advance. And for the outer planets, what we do is we pick the time when they're at opposition. And that means that it's opposite from the sun, from the Earth's point of view. And that basically gives us the highest resolution view. That's when Hubble is the closest to each planet, even though that doesn't vary much over a year. And the planets are a little bit more challenging because they move. And so Hubble has to find guide stars first that tell it where it's pointing in the sky, but then it has to track those planets. So it has to move following the planet across the sky. And so that has to be interleaved with all the other science program Hubble is doing every single day. And so it's very carefully coordinated to fit in as Hubble then orbits around the Earth. And so it gets planned out down to the minute of exactly which image we're going to take in which filter for each of those planets. So it's a cosmic dance of getting Hubble pointed in the right place, moving in the right direction, and tracking all at the same time. The OPAL project, or the Outer Planets Atmospheres Legacy Program, is an observational program using the Hubble Space Telescope. And what we're doing is we're looking at each of the outer planets every year so that we can build up a time base using the exact same facility and the same instruments so we can actually track what's changing over the years on each of those planets. And it started really with Jupiter. In essence, we were trying to look at the weather on Jupiter. And as we're trying to understand weather, we know even here on Earth it changes every minute, every hour, every day. And we didn't have that kind of time coverage, but we also didn't even have long time coverage to look at things that changed over seasons. And so we had this big gap in our knowledge where we just weren't getting frequent enough data to be able to trend any of these things. And the idea kind of came about to look at a legacy program where we built up a legacy for Hubble within the planetary community. And in 2014, we started with our first observations of Uranus. And the first thing I think we noticed was Uranus had a very prominent polar cap. It was very much brighter and getting brighter over time. We've watched it over the last few years get much brighter. Neptune, on the other hand, has been really quite interesting. The first thing we noted was it had a lot of bright white clouds, and they were coming and going pretty rapidly at a lot of different latitudes. And so when we start looking at Neptune and Uranus as dynamic planets with changing atmospheres, weather, like we know now for Jupiter and Saturn, we realize that we have a lot of gaps in our understanding. And so we've been able to use the OPAL program to track how much cloud cover we have from year to year. But the other thing we can do with Hubble that we can't really do any other way is look for dark spots. And so the Great Dark Spot was this big iconic feature we saw with Voyager. And when we looked again a few years later, finally when Hubble was online, it was gone. And that kind of surprised us because we were used to the Great Red Spot, which doesn't go away. It's changed over time, but it's still there. And so these storms are not quite the same as what we see on Jupiter because they form and go away on much more rapid timescales. The latest image of Neptune is really interesting to me because we don't see those bright white clouds we've been seeing the last few years. As a matter of fact, the only thing we see in that particular image is this great dark spot. And so in a lot of ways, it brings us around full circle because this looks so much like the Voyager image from 1989. And that was pretty surprising to me, not to see as much cloud activity as we've been seeing in previous years. The OPAL team is actually a fairly small team. There's only 3 of us, but our data is immediately available to the public and any other scientist that wants to use them. And so we do that as well as our own scientific analysis. I think having so much Hubble data now, there's just so much in there to study. And as a scientist, that's what drives us, is trying to solve mysteries, trying to look for new mysteries. And so having these long-term data sets with just such rich numbers of features in there, there's always something to go look at. And it's certainly going to keep us busy for years to come, even when we're not getting any more data.